We're on page 462, volume. Okay, how do I measure, how might I measure this?
A ruler.
Okay, a ruler, a length with just like inches or something,
Yeah.
right? How do I measure, so that's how you measure a length. How do I measure this? Squares. Maybe square inches, which would be about like that. How many square inches fit in here? How did we do that? Base times height. Okay, and you know, we did circles and all kinds of stuff. But how do I measure the size of this? Right. Yeah, usually they use the words length, width, and height for rectangular prisms. You kind of have to use your imagination. I used to have a box. I wonder whatever happened to that box. Did you guys see it in middle school, that colorful?
Yeah.
It was a square, a cubic foot. So you measure three-dimensional shapes it's called volume. This is an area, right? This is called a volume. We also did surface area, I guess, last, couple months ago. Surface area is how much fits on the outside. Volume is how much fits on the inside, though. And it's measured in cubes. Area is measured in squares because it's two-dimensional. Volume is measured in cubes. So I don't know if I can draw a little cube. You gotta kind of use your imagination there. Anyway, how many cubes can fill up the space? And basically, if I wanted to figure out how many cubic feet filled up this room, how could I do it?
I really don't know.
This is where the box
Oh,
comes
it's
in.
length times width times height.
Well,
Right said that.
you could say
No?
how many cubes fit on the floor, right? And then, you guys remember how big these tiles were?
Like 18 inches.
What?
1 by 1.
1 foot by 1. Yeah, it's a square foot. So imagine a cubic foot sitting on top of each of these squares. And that would give you how much was on the ground. And then if you just multiplied how many feet are in the room, that's like how many floors are there are kind of. That would tell you how many, like, so I think we did this once as a problem, didn't we? Like, what's the area of the floor?
Yeah.
I don't remember what it was. I think it was like 300 and something, or maybe 400. Okay. Anyway, you guys found it by doing the length of the room times the width of the room, right? You just multiply these two together. That gives you how much is on the floor, and then if that's area of the room, but if we're counting volume, you would multiply that by how many layers of those layers can fit, so you have to multiply by height. So if it's just a rectangular prism, it's length times width times height. Sometimes, and that's kind of the general rule, it's length times width gives you the area of the base, right? Like the ground floor. If we have a cylinder though, that's going to change. This is like a couple days from now. Or, whatever the shape is. You basically find the area of the bottom, and then you multiply that times the height of the prism or whatever the shape is, and that gives you the volume. Does that make sense?
Yes.
Okay, one person, I'll take it. One person got it. All right. There are some tricksy tricks that they're going to throw at us here. I really don't think you need help on the first 8, but let's go ahead and I'm going to be doing the odds with you. Page 462, 1 through 18. Page 462, 1 through 18. Okay. So how could we find the volume for number 1?
You just add the thing.
4 times 4 times 4. What's another way of saying that? 4 cubed. That only works on what shape? Cubes. 4 cubed. And that's why they call the exponent of 3 cubed. Okay. So anyway, 4 cubed, and you actually have to do it. How do you think we would label the answer?
Square
Units cubed, that's right. So, what's 4 times 4 times 4?
64.
So, it would be 64 units
Or you get 3.
cubed.
Well, you say cube, but what if you don't have the number for cubes? I mean, you just say 3.
You have to figure it out, I guess. Okay, what should we do on number 3?
9 times 3.
Nope, number 3.
Oh, number 3. 7 times 2, but then you have like 14 and then times
That's
5.
Does order of multiplication matter when you're multiplying stuff? No.
Yeah.
So you could do 5 times 2 times 7, that'd be easier.
8.
No, try again.
70.
70.
Dang, two grand.
5 times 2 is 10 times 7. 70 units cubed. See how quick and easy these are. So easy.
Wow.
This is why I don't do math.
They're setting you up for.
For failure.
Number 5, a cube with edges x.
X cubed.
X cubed. Units cubed. That looks weird, but okay. They actually write out cubic units like in words, but it's inefficient. Number 7, if your bedroom were 15 feet long by 10 feet wide, by 8 feet high, how many cubic foot boxes would fit into the room? So what do we do?
15 times 10 times
8. Yep. Yeah. Basically 8 times 15, what is that? 8 times 5 is 40, 8 times 10 is 80. So 80 plus 40 is 140. Times the 10, or I said that wrong.
it's
120. Times the 10 is 1200. What did I say wrong? 8 times 40 and 80, yeah, okay. Alright. Now, are we to the tricky part yet? Number 9, yes we are. Okay. It's a cube, but they don't give us the length of each side. So what should we do? What should we do for number 9? Any ideas? They only give us one number. And that's the diagonal of one side. It's 10. One diagonal. What we really need here is x, right? Or this x. There's a relationship that we know. Huh? Pythagorean theorem. So how would I write that? Okay, notice we're not using a and b here. We're using the same variable. Why is that?
Because it's a cube and then
Because it's a square, so the lengths are the same. So I could have put a squared plus a squared if I wanted to. What is x squared plus x squared? 2x squared. What's 10 squared? 100. Now what?
divide.
Divide by 2. What's that give me? Now what? Square root. Okay, now your calculator could give you a decimal. Some of your calculators could actually simplify the square root. Do you guys remember how to simplify a square root? What goes into 50? What goes greater than 25.
5 times 3.
Have we done this year or
Yeah.
not? We did?
Is it? Are you sure?
Or is this last year?
I think we did.
Anyway, the doubles come out as a single. So this is 5 squared, and then the leftover stays inside. It's 5 square root of 2.
Go back there.
You guys weren't here last year. Did we do this year?
Yes. I think,
Could we?
we just came, everybody already knew you came in, because we did
But
this.
we haven't done it this
Yeah,
year.
we did it last time.
Okay, yeah, we did that last year. Okay. Anyways,
You didn't like it last year either.
you didn't. I thought that was your favorite part.
Mm.
Okay, so that is one side
You have to do that.
of the square, which is kind of one side of the cube. So how do I find volume of that?
Do that times that times that.
Yeah. Okay, Casios can actually do this without. The rest of your calculators will spit out a decimal, which is not what we want here. So remember, order of multiplication doesn't matter, right? So I can do 5 times 5 times 5. This just means 5 times square root of 2 times 5 times square root of 2 times 5 times square root of 2. The parentheses don't really matter because order of multiplication doesn't matter. So I multiply whatever I want. 5 times 5 times 5.
125.
Okay, what's square root of 2 times square root of 2?
Square root of 4.
Which is
Yeah.
2. Whenever you take a square root times itself, it always just becomes a normal 2 in this case. Times another square root of 2, those don't mix. Okay, you can't. Square root of 2 times square root of 2 is 2, but if you do it times another square root of 2, that doesn't really mix well. It turns into a weird decimal, so we just leave it alone. 125 times 2. $250. That problem will wake you up, right?
No.
And that's why it's in the B section.
You should do the rest of the B section with us.
Now I'm doing the rest of the odds with you. Boo boo doo doo boo. How about, does anybody have another? I'm not going to do, well, 10 and 11 are the same right there. Okay, let's do 11 then. 11 looks a little easier to me, actually. Any ideas for 11?
You can do
Alex
3
and-
times 3 first.
What is it trying to make us find?
The volume.
So we don't need any of the stuff in the middle, we can just ignore it?
No, we need
can
it.
use the stuff in the middle to
We
find
need it because they don't tell us how deep
Mhm.
the prism is, how far back it goes, like from front to back. Because remember, you need like length times width. I guess this would be called the width of the
My
base.
person wrote it in.
Okay, go ahead and erase that then.
Yeah,
Okay, and we also need the height of the prism. They don't give us the height of the prism. How could I find the width of the base?
5 squared minus 3 squared.
Right. 3 squared plus w squared equals 5 squared. You guys see where she got that? It's not quite what she said, but that's basically what she meant. Okay, Pythagorean theorem on the base. If it is a rectangular prism, we know those are right angles, so we can use Pythagorean theorem. 3 squared on the bottom, 3 squared plus the width squared would equal that diagonal square. Yeah, you guys remember this triangle? 3 blank 5, 3, 4, 5. That's one of the triangles that makes a right triangle. If you subtract 9 on this one, you get w squared is 16. 4 squared is 16. So anyway, the width of the prism is 4. How many sneezes is that for you today?
A lot. You can squeeze that whole first time.
Is your mask like what, soaking wet in there?
No, I just have allergies, so it's just like
Yeah.
midwinter, so now
Midwinter allergies.
I'm assuming it's allergies. But I'm not sick, because the first thing that happens when I get sick is my throat gets sore. And I feel fine, except for my nose is just like, yeah.
Yeah. Yeah, if I wake up with a sore throat, that's trouble. Okay, how about the height? Anybody got an idea for the height?
Eight.
Yeah, you gotta kinda use your imagination, but we got another right triangle, the 5 and the 8. The 5 and the 8 diagonals make, we'll make another right triangle. This would be the height of the prism. So it's 5 squared plus height squared equals 8 squared. This one's not gonna come out as pretty. What'd you say?
Does it matter how I say it? So if I say 8 squared minus
No.
5 squared?
That's an easier way, but if I write it the same way every time, it's less likely to confuse people.
Okay.
25 plus the height squared equals 64. So if I subtract 25, I get 39. Does 39 have a nice square root? Does it simplify? What goes into 39?
Nothing. Well, 1, 30,
There's something.
3, 13, 13.
3 and 13. But those are primes. There's no doubles, right? So
It's just a square.
square root of 39 does not simplify. Which is kind of good news, because it means we don't have to mess with it very much. Alright, so we need length times width times height. What's the length of the base on number 11?
4.
Well, 3 or 4, depending on which direction you want to go with it.
Well, one of them's 3 and the other one's 4.
Okay.
And the height
The length and width are 3 and 4, so 3 times 4, and the height was that thing, square root of 39. So 3 times 4 is 12, times square root of 39 is 12 square root of 39.
How do you do number 4?
Number 4,
Yeah, it says the cube edge measure.
it's a cube.
So it's a cube, yeah.
Okay, number 13. Anybody have bright ideas for that one? There's a couple ways you could do it. Cut them into 3 different boxes. Find the volume of the 3 boxes. There's another way we could do it. Does anybody know another way? Might be slightly easier the other way.
Find the volume of the whole thing and then cut them together.
Right. Find the volume of the whole thing as if there was not a hole in it, and then subtract the volume of the hole. H-O-L-E. Hole.
How do you find the hole?
How do you find the hole? Well, you pretend there's a little box in there and you find the length, width, and height and multiply them together. So pretending there wasn't a hole, what's my length from left to right?
9.
9. You guys know how she got that? 3, 3, 3, going left to right. What's the width from front to back? 3. What's the height of the box? 7. So if there was no hole, let's see, 21 times 9 is 189, I believe. This would be our answer, but there is a hole. What is the length of the hole? Like left to right.
Is it 4, 3, and 3? Isn't it?
From left to right, what's the length of the hole?
3.
What's the depth of the hole, like the width of the hole? 3. And what's the height of the hole? 4. So the hole is 3 times 3 times 4. 9 times 4 is 36. So if we take out the hole, we're left with the actual 1, 5, 3. So I don't think you're going to be able to use that trick on 14. You will have to find the volume of all 3 boxes and add them together. Notice that back box is not 4 tall. You guys know what I'm saying?
Yeah.
It's 7 tall. So,
The rest behind it.
yeah, it's in the back. You gotta kind of use your 3D imagination. But the back box is not just 4 tall; it's actually 7 tall. Okay. Number 15. Find the volume of a cone. No. With diagonal cube. Sorry, I said cone. A cube with diagonal x. Oh boy. We kind of did this on number 9, right? I guess we could put the diagonal wherever we wanted. All the sides are the same. Diagonal is x. Remember what we did?
X squared.
Well, since I called it x, I'll call those a. Then what did I do?
Two.
This one is a mess. Okay, I'm gonna speed up just slightly. Okay, divide by 2, right? Then what do I do? What's the square root of x squared? X. What's the square root of 2? Square root of 2. Okay, here's the thing though. By the way, if this was an algebra problem, you should put positive or negative this whenever you use the square root trick. But since the negative length doesn't make sense, you don't have to do that on this one. Okay, you're not supposed to leave a square root on the denominator. So you do this. Did we do this year? Probably not. Maybe when we did some Pythagorean theorem problems. So we have the top is x squared of 2. X times square root of 2. The bottom is square root of 2 times square root of 2, which is 2. Okay, you're not supposed to leave a square root on the denominator, and that's how you get rid of it. This is like multiplying by 1, when you multiply by the top and bottom by the same thing. So it doesn't change the value. Anyway, this is one side of the cube. So what do I do with this? Cube it. Okay, this is where the fun starts. Alright, what is, everything in here is going to get cubed. What's x to the third power? X cubed. Let's do the denominator. What's 2 to the third power? 8. 2 times 2 is 4 times 2 is 8. What's square root of 2 to the third? We kind of did this one earlier, remember?
It comes out and then into the.
Right, it's 2 square root of 2. There's one more thing I can do to that.
Simplify.
1 times this stuff just kind of disappears, but the 4 is left behind. So x cubed square root of 2 over 4. That would have been a good bonus problem. Do you guys think you could have got that one?
I remember it now.
Now you can do it, right?
Now I remember learning it last year, but
Which
that
part?
was like my least favorite thing we ever did.
Like simplifying the square?
All of that.
The whole thing? Very tough, huh?
That was awful. I hated that last year. It's my least favorite thing.
Okay, 17. How many grams of mercury must be poured into a rectangular container with dimensions 12, 18, and 10 in order to fill it? The dimensions of mercury is 13.6 grams per cubic centimeter. So that one's not nearly as hard. Does anybody have an idea of what they mean or how we could do it on 17?
Well, you could figure out the area of the actual thing first.
The volume.
Um,
Find the volume of the box you want to put it in, and then what? They're basically saying you can get 13.6 grams of mercury in a cubic centimeter.
So once you get it, multiply it by 13.
So yeah, you just multiply the volume of the box by 13.6, because the volume of the box is going to be in cubic centimeters. And that's all you have to do on 17. 18 looks like a mess. Can you guys see what they're doing on 18? Can I see what they're doing on 18? It's a
What the heck?
kind of a Tetris shape. You know what I'm talking about?
Yeah.
It's
Oh.
I don't know, kind of like shallow end, deep into the pool thing.
Yeah.
All right, so it's going down. All right, why don't you guys give that a shot? And if you have any questions, you can ask.